Hello, Matthews Gatos here. In this video, we're going to look at how do we relate an equation with its characteristics to the number of solutions. In this particular question, we're looking for the equations that have two distinct, that means different roots. So you'll notice we have factored form, vertex form, and standard form. So let's start with our equations in vertex form first. So for my first equation, I know that A is less than 0 and B is equal to 0, but I don't know about C. So I could have two possible equations. So I'm going to have negative x. Now, if C was positive, I would have x minus C being positive. But if C was negative, I would have x take away a negative is positive. This would be C negative. So in this situation here, I know I have a parabola that opens down with an x-intercept of C. And potentially, again, if C is positive, I would have an x-intercept here. That would be an x-intercept of C. You can see I have two x-intercepts. If C was negative, my x-intercept would be over here. And again, I would have two x-intercepts. So for this particular equation, I can say, yes, this one has two distinct solutions. Let's look at my second one. In my second one, A is negative, B is 0, and C is positive. So if we know that C is positive, we've already seen that one. Negative opens down. X minus 0 means the x-intercept is at 0. If C is positive, it means I've moved to the right. So my equation would look like this, and yes, have two x-intercepts. So those were my equations in factored form. Let's look at equations in standard form. No, vertex form, sorry. So in these vertex form equations, in the first one, A is greater than 0, H is greater than 0, and K is greater than 0. So I have a parabola. Since A is positive, I know that it opens up. H is positive, so it's moved to the right, and K is positive, so it's moved up. So you can see here it does not intersect the x-axis, so this is not one of my potential solutions. In the next one here, equation number 4, A is greater than 0, H is greater than 0, and K is less than 0. So since A is positive, I have a quadratic that opens up. Since H is positive, it's moved to the right H units. And since K is negative, it moves down. And I can see here it has two x-intercepts, so this one has two distinct solutions. Okay, let's move on to our last one, which is the equation in standard form. So the equation in standard form, what do I know? I know that A is positive and C is positive. So it's really hard to picture what the graph of a quadratic in standard form is. So I'm going to use the discriminant to help me with this. So my discriminant is going to tell me the nature of the roots. So my discriminant, b squared minus 4ac. So it really doesn't matter whether b is a positive or negative value, because when I square it, this will always be a positive value. Now I know that my a value is positive and my c value is also positive. So I am subtracting a positive number. So in terms of my discriminant, I'm having a positive number. Subtract 4 times 2 positives is also positive. Now, to have two distinct roots, my discriminant has to be greater than 0. In other words, b squared minus 4ac has to be greater than 0, or b squared has to be greater than 4ac. To know if this is true or not, I really need to know more than just the sign of the number, whether it's positive or negative. I need to know the value, because if b is a really big number and I square it, it's always going to be greater. But if b is a really small number, it might be less than. So I don't have enough information to say about equation 5. So my answer, how many equations, which equations have two distinct roots? It would be equation number 1, equation number 2, and equation number 4. So I hope this video helped, and I look forward to seeing you for the next one.